Okay, so data structures are very useful. They exist in every other language, and Python does them slightly differently in some ways, but it's not that different. So we'll look at the four types of this data structure, of these data structures now. So, first let's look at indices. We already learned about these when we were looking at strings. Indices help programmers track elements. So in this list or whatever data structure this is, the index is 0 and there's some value 11 stored there. And these are contiguous memory locations. We don't need to know about those right now. So we can just worry about the indexes. They start at 0 and go on forever. And I mean for until the length for the length of the whatever data structure it is. So lists are basically dynamic arrays. They can be mutated. Their order matters. So you can it's not the same for A and B to be in the list, and B and A, that because the order matters. And then allows elements to be added and released, automatically allocates and releases memory. So that's what a list is. So there are some functions to add in a list. You would use append because it adds an element at the end of the list. And to pop an element to or remove an element at a certain position, you would use dot pop. To clear out the list, you would use dot clear. To copy it, you would use dot copy. These are very helpful functions, and some of them don't really exist in other languages. So this is where Python excels because it even has dot sort. So very good functions provided for your use. So we have nested lists. Nested lists are basically um, 2D arrays. So they're two-dimensional in nature. They're 2D lists. So you can have a list inside of a list. You can have multiple lists inside of a list. So this list is at index 0. This list is at index 1. And then inside each of these lists, there's some numbers, um, 1, 2, 3, 4, 5, which also have index values. And that will be important when we go on to the next um, when we go on to the next slides. So we're gonna loop through nested lists. So like in other languages, we can loop through nested lists. So for I in list, and for j in I, we're gonna print j. So this is basically how you would loop through it and print j. And if you do this, it's just gonna go in this order where you do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can do it the opposite way as well, and that would result in a different order. And we can see, I'll show that to you in a demonstration. What would happen if you switch the orders. List comprehension. So list comprehension is basically a concise way to create lists. So new list equals expression for item in iterable if condition equal true. So just ignore that for now and look at this. So it says we have some fruits, apple, watermelon, kiwi, and new lists and we're using list comprehension to make this new list. So x is the x is just the variable we're going to be using throughout this statement. So for x in fruits, for fruit in fruits, for each fruit, if a is in the fruit, then we're going to add that to the new list. So a is in apple, a is in watermelon, and a is not in kiwi. So the new list is going to be apple and watermelon. And how you would normally do this is just make an empty new list, use the apple, watermelon, and kiwi, and put for x in fruits. If a is an x, then new list append. So this is the normal way to do it. This is the more fancy way to do the same thing. Alright, list comprehension with the previous example. This is how you iterate 2D arrays using list comprehension. Um, for I new list for j and I print j. Instead of that, we're going to do print j for I and new list for j and I. Tuples,
Do you
fruit.
want to demonstrate some of the lists? Uh, like example, like give some examples. In like VS Code.
Oh, VS Code. Okay, so, oh wait. So list equals, no, fruits equal kiwi, watermelon, I don't even know, banana. So for this, we can, if you want to loop through this, you can just do for fruit in fruits, print fruit. And this is a more descriptive way of doing it because you actually know what you're iterating over, and it's gonna print all the fruits in the list. If you want to be more picky, you can just do if a in fruit, then only print that. So yeah, since watermelon and banana are the only things that have a, you can print that as well. And we can also make a 2D array. So we can make courses, and this is useful for like this instance where we do biology and chemistry, but then we want to separate that from uh, calculus and I don't know, geometry. This is math, this is courses. Oh no, this is science. So you can separate those. And then for I in courses, for J in I, print J. So it's gonna print biology, chemistry, calculus, and geometry. And oh, we can do list comprehension. So we can do the same example as before. So fruits equal apple, kiwi, watermelon in no particular order. And then we can say better fruits equals x for what was it for x in fruits? Oh, for x in fruits, and then it was wait, if a in x. It doesn't have to be a, it can be something else. So, oh, for a, you can do I don't know I. So we can just for print better fruits, and that's kiwi. Is that it?
And you can also demonstrate like basic indexing. Yeah, like getting specific elements out of the
Oh,
list.
oh yeah, I forgot methods. So print fruits dot um what is it in Python?
No, it's just the brackets. It's just
Oh, it's just
brackets.
okay. It's just wait.
Yeah, it's just,
So it functions as sort of an array. Um. So yeah, the first index is kiwi, and then the zeroth index is apple. And then I was saying we can do fruits dot clear, and that's gonna clear everything, and you're gonna get none, which is basically like null but not. So it indicates that there's nothing there. So let's go boost up append. Let's add something to the end. I don't know. Uh oh wait, not like that. So print. We have to put that different. Fruits dot append. I don't know. And fruits. And if you do that, then I don't know is going to get appended. And then you can also do fruits.pop, which is going to remove the last element. So watermelon was removed. And then I don't know what else.
Like you can show the multi-dimensional list,
Okay.
and just like getting just like indexing that.
Okay, so print J. So this is how you generally loop a 2D array for I in courses for J and I. Um, what do you want me to do now?
Just like in like get specific elements out of the 2D
Oh,
array. Just like
like
indexing. Yeah,
that.
just
Okay,
index.
print courses 0, 1. So because this is the 0th index, 0th uh, index in the first list, we're gonna go to it, and then the first index in the the first index in the 0th list of this of the whole total list is chemistry. So 0 and then 1, and then you can actually just remove. You can perform the same operations there as well. So append I don't know. Oh, and then you have to do that outside. I keep doing that because you want to see the new list. Courses, biology, chemistry, I don't know, calculus, geometry. Okay, I think we can move on to tuples because we still have three other things to cover. Uh, okay, wait, let me change. List functions, list comprehension, tuples. So uses parentheses instead of square brackets, order matters. It is unchangeable, which means after you define a tuple, nothing can add or remove elements from it. And then it also allows duplicates. So yeah, if it's basically like an enum of some sort, where you just can't change it. It's just like that. And then also the order matters, but you can have duplicate stuff. So that's one good thing. And then you have tuple.count, tuple.index. So you search for the tuple for a specified value, and it returns the position of where it's found. So where the index of that of your query is. And then for .count, it's going to return the number of times a specified value occurs in a tuple, because of course it allows duplicates. Sets use curly brackets. They're unordered. Once a set is created, you cannot change its items, but you can remove items and add new items. Unlike the others, there are no indices. And then here, duplicates are not allowed because it is a set. So in sets, you can't have duplicates, and they're all over the place. But uh, yeah. Oh, and there's no indices because obviously it's unordered. So you can't have indices for something that has no order. And then obviously a lot of functions here. So adds an element to the set here, removes all the elements from the set. Um, you can see here it says once the set is created, you cannot change its items, but you can remove items and add new items. So here we can see that we can add new items, we can remove all the items, and so on. And also here we can remove an element from the set. You can also remove the specified element um, of the set. Dictionaries are used to store data values in key value pairs. It is, oh wait, let's go. It is essentially a hash map, and they are ordered, they are changeable, and of course in dictionaries you can't have duplicates. It's essentially like a hash map, You put a key and then define it using a colon. You can access members of a dictionary by using the key name instead of the index number. So, and also, you have fast lookup times because that's just the nature of dictionaries. There's like probing and stuff, which we will not do, but that's how hash maps work, where they handle collisions and do all sorts of stuff behind the scenes using arrays, not arrays, lists, I guess. So we have dictionary functions dot clear, dot copy, it's pretty much the same as the other ones for those two. And then the main ones are .get, where you return the value of a specified key. And then you also have .keys, return a list containing the dictionary's keys. .pop removes the element for the specified key. So you can go over these, look them up also, and see if you're working on something and you might need to use a dictionary function. You don't have to memorize them. You can just use the documentation. Uh, yeah, arrays. There's no native support for arrays in Python as opposed to other languages. Uh, this is very unique to Python. Almost every other language has arrays, but Python is there's just not for some reason. You can use an array library or NumPy, um, but that is for a later time. And also we have pass and continue keywords, which we did not discuss last time. So pass, it acts as a placeholder when a statement is syntactically required, but you don't want to execute any code. So basically, its usage is empty functions or class placeholder for future code. In loops or conditional statements, when you want to do nothing for a specific condition. So if I equals 2, you don't want to do anything. Maybe in that specific case, you don't want to do the operation that you would do for the other cases. So you'd use pass, move it on, and you'd go on to else and do whatever you want. And then continue. Its purpose is to skip the rest of the current iteration of a loop and moves on to the next iteration. So usage in loops when you want to skip certain iterations based on a condition. Um, so if you have I equals 2 and you don't want to print I when it is equal to 2, you just continue and move on to when I equals 3. And I equals 3 will be printed. So 0, 1, 3, 4. So 2 is skipped. Okay, let's go back to tuples and do those in VS Code.
Yeah, we can just give a demonstration for all of them since we already covered them.
We can do what?
We can do a demonstration for like all for tuples,
Yeah, yeah.
sets, and dictionaries. Yeah, yeah.
Change windows. Go live. Okay. Let's see. Okay, so we're gonna make a tuple. My tuple equals hello, hello. I don't know. And print my tuple just to see what would happen. And then obviously it's gonna say hello, I don't know. Um, and then you can see that if you want to change it, you can't really change it. There's no method here for you to change it. So that's one of the qualities. Oh, and then we can do I don't know again. Oh yeah, we can do I don't know. So that's the property of tuples. You can have duplicates. And then obviously you can iterate over it as you would do any other thing. So for I in my tuple, print my tuple, print I, and then hello, I don't know it. So that's how tuples work. Let's move on to sets. Because tuples are unchangeable, there's not much to discuss there. My set equals, I don't know.
Yeah, yeah. Just to like, yeah. While Rithik was working on this, there are just two main methods for tuples, and that's the count method, which basically just returns the number of times like a value occurs in the tuple, and index just returns like the index or position of where like an element is found. So yeah, you can't. There's not too much functionality. Yeah.
So yeah, print hello, I don't know. You can see I did this two times just hoping that it would print them in a different order, and it did. Sets don't have any order, they're random. So we have hello, I don't know. And in this case, we had I don't know, hello. So that's uh I was just demonstrating that functionality. And then also I wanted to show if you did hello again or hello, I don't know, and we print, you can see that it doesn't really recognize the second hello because it doesn't recognize duplicates. So I was just showing that as well. And then we can also do my set dot clear. No, that would clear the set. So I don't think we need to run it because we already know what happens there. Oh, we can add. So let's add my name. Oh, and then print. Oh, let's do a for loop. So my for I in my set equal not equals print, and we can see that it's gonna print I don't know my name and hello because we added my name here. So I think that's it for sets. There's no indexes because it's unordered. There's a bunch of other functions which we could still explore in your own time. Now we can do dicts. So this is a dictionary. This is a key value pair. So name one is key, Ritwik is value, and that's a pair. So to uh, to look at what these are, this is essentially a hash map. They are ordered, they are changeable, and we can't have duplicates because that's an inherent property of hash maps or dictionaries. And then you have fast lookup times and so on. So my dict, wait, actually let's do print and see what would happen. So it's gonna print. Python is very I don't know what to call it. It's slick or something in the way that you can just print the object and it's gonna put that in a string form for you instead of giving you a random memory location or something. So that's good. So you can do print this dot we can get something because it is ordered. Oh, we can get something. I don't know. Oh, we can do keys. So keys is gonna give you name one dot na and name two. Um, so yeah, that's just the key. So name one is the key, name two is a key, and we print those. We can also do that for values, mydeck dot values, Ritvik Alex. So that's interesting functionality. You might want to think about where you use that. And also, I haven't shown you the copy functionality. So this is actually a copy. This isn't the same thing as my dict. Um, so yeah, I was just showing that. And what other things? Oh yeah, I realized we can't. Can we add to a Python hash map?
You should be able to.
Because in Java we can add. Uh,
Okay.
okay,
Okay.
so
Well, yeah. Do we have any questions?
Yeah, if you have any questions. Yeah, this is recorded.
Yeah, so like the big thing about like the dictionaries is that like you can't necessarily add elements, but you can update elements or just change them.
Yeah. I don't know how to use this one. Let's see. I don't think I've ever used a Python hash map. Let's see, name one. Oh wait. I guess this should how it works. Is this like
Okay, we don't have to worry about that now.
yeah, we don't really have
Uh,
to okay. I'll
yeah.
do that later. Let's go to the other slides. But I will do that. Functions and lambda. So what are functions? Sometimes you need to repeatedly use a certain piece of code. To make the process compact, just use functions. Use the def keyword to denote a function. Use the return keyword to return a value. And then functions are first class objects, which means that functions in Python can be used or passed as arguments. So function is basically it's you just think of it in mathematical terms. So f of x equals some polynomial. Uh, it's actually in a very a similar way, but instead of like a polynomial, you're just gonna have some sort of, we're gonna do some operations with the input, which is x. But here we can have multiple inputs, uh, and so on, which we will show, and those are called arguments. So, okay, first class functionality. This basically means that you can make the function as a variable. So this is quite unique to Python. At least it's not popular among the very big languages. Um, so you can make the function a variable. So that's what it is. Arguments, you can pass in parameters into a function. The function can then use these values. Functions must be called with the correct number of arguments. So if there's three arguments uh, in the function, then you have to use three arguments when calling it. And there's like different nuances to this rule, and we'll see what it is. Oh, it's right here. So arbitrary arguments. So if you do not know how many arguments that will be passed into your function, add a star before the parameter name in the function definition. This way, the function will receive a tuple of arguments. So here we can see that we have a star args. So that means we're gonna be able to pass in as many arguments as we would like. Um, so yeah, print all args 1, 2, 3, hello. So these are all arguments that's being passed in here, and we're gonna print all these arguments out. So 1, 2, 3, hello, 1, 2, 3. Uh, so that's pretty much it. You can have several arguments, and this is a very cool functionality of Python. Keyword arguments. This is if you want to be more express or direct in how you call functions, or if you want to actually if it's actually necessary in certain cases. If some arguments, if you want to send them in a different order. So yeah, the order doesn't matter, can also send arguments. Okay. So you just do name equals Alice instead of just putting Alice. And this age equals 30 could have been the third argument passed in, and it still would have been fine, because you're expressly stating what the argument is. Um, keyword arbitrary arguments. So that's called kwargs with the double asterisk. So if you don't know how many keyword arguments that will be passed into your function, add the double asterisk. before the parameter name and the function definition. So this way the function will receive a dictionary of arguments. So we're gonna have per key value in corgs.items. So basically it's just a dictionary. So name equals Alice, age equals 30, city equals New York. So what if sometimes you may not have a city and you just have name equals Alice and age equals 30 and that's all you know about Alice. In that case, this Quark's system would be very beneficial because there's some ambiguity in what you're trying to pass in. Default argument, if you call the function without argument, it uses the default value. So if you to declare a default value, you can just put after the parameter, you can just put equals whatever the default value is. If it's an integer, put an integer, um, or whatever object. So a definition of name greeting equals hello. So hello is the default greeting for this function, but sometimes people may not want to say hello. They may want to say hi or howdy or something. So that's where default arguments can be beneficial, but also overridden when necessary. Um, A function decorator is something which we really don't have to worry about that much, but it takes another function and adds onto its functionality without explicitly modifying it. So we have a definition, no, we have a function. So my decorator func function, and this is the wrapper of the function. So you print something is happening before the function is called, function, and then print something is happening before the function is called. So this is where you want to do something, some stuff before you call a function and after you call function. And it may not be obvious why this might be necessary, but sometimes it is. So here you can just put in the function. So say hello, print hello, and we're going to use the my decorator wrapper for this function, and you can use it for other functions as well. And just say hello, and you can see that something is happening. Hello, something happened. So lambdas are a way of shortening functions. They can have a number of arguments, but only one expression. So here we have x equals lambda abc, and then colon a times b times c. So this is multiplying all of a, b, and c together, and we're gonna print x of 5, 6, 7. So x is basically the lambda, uh, a lambda, and it's gonna have these three parameters. You're gonna do something there and then print them out. And the main thing to note with this is that you can only have one expression after the colon, despite you being able to have any number of arguments. Okay, so we can do a demonstration. So class.py, wait, okay, wait. That's for later. Let's just do it in here. So um oh yeah, so definition. Def add ab, and that's a plus b. So that's a pretty basic function where we're gonna have to return so it's a pretty basic function where we return a plus b, and then we can just do add 1 2, and then print, so print 3. uh I'll go in the order of the slides based on what we did because I will forget. So we did arbitrary arguments next. So definition, add, oh, and we can just put args here and then put an int, not int, why am I doing that? I equals 0, and then we're gonna do for arg in args, we're gonna do I plus equals arg, and we're gonna do print 1 2, and then now we can do as many as we want. So let's add in all of these. I don't know what the result is. it's 15. So we can just run this and see what happens. Oh wait, let's see what I did wrong. Add. Oh, we didn't return. Oh, that's stupid of me. So we return.
Yeah. Yeah,
Uh,
and the return keyword is like pretty important when you're working with functions, and it basically makes it so basically you return basically it just returns the output of the function. It doesn't necessarily print it to the command line, but with the return keyword, you could for example like add the output uh, of two different functions, and then you could print that sum. Whereas like if you just use the print method, then you'd be adding like basically like two print methods, which doesn't really work. Yeah, so just like return keyword, pretty important. It just allows you to use the output of your function for other stuff that isn't printed.
yeah, and I needed to get a formatter. So because that was not good. So keyword arguments. Oh, this is just the. Oh wait. So let's just make a completely different function so we can use keyword arguments. First thing, name, age. Let's make the default. Oh wait, no. Let's make the default city. I don't know, NYC. And let's do. Oh, not that. Let's do print name, age, and a city. And then here let's make the function person, not function, 7, 12, I don't know. That doesn't really matter. City equals. Oh, and you don't, I didn't use, wait. Okay, so it's gonna print this, but let's just say I didn't add in city, and I'm gonna use the default one. So we're gonna get that I live in NYC. So that's the default setting. And then also this age doesn't have to be in the back. It can do that because we're explicitly stating what that is. So that's what keyword arguments are. And then there's keyword arbitrary arguments. So keywords. Let's just print key, and then let's just do that. So it's gonna give us a dictionary. Age is 2, 3, 4, 5. Name and is Ritwik. So that's what a keyword argument is. Oh, and then we already did default arguments. Oh, let's do lambdas. Um, and so because this has this Python lets us put functions as variables, we can do this quite easily. Lambda x y is x plus y. Oh, let's just do x times y. So that's a very sleek function. Let's multiply, actually, not addition. Multiply, and then print multiply 1, 2, 3. Okay. So that's 6. And then obviously lambdas have as many expressions, sorry, as many arguments that that you might want. So z, and then let's also multiply all that by z, and then let's do 2 to get 12.
Yeah, and just like remember for lambda, like basically the variable you set the lambda to is basically your function name essentially. So you just call that variable to basically call the lambda.
Okay. Is that it?
Mm, should be. Do we have any questions? Okay. Okay. Well, I'll take the listen now. We can go over homework. I think.
Oh,
Yeah.
okay. So this is the other homework. This is the other homework. So this one was asking you to create a list of foods, print every element of it, remove the first element of that list, and print the updated list. Loop through and print every single element of a nested list with list comprehension. Create a dictionary and print only the keys. Now print the values for each of those keys. So we went over the methods for this um, during our demonstration. So that should be good. Then the homework here, create a function that takes in two numbers. We did this during our demonstration actually. Create a function with the args keyword and loop through each arg. Okay, pretty good. Create a lambda function that square roots each number given to it. You can choose the number of arguments, just do like one or two. Let's do like two or oh wait, not square roots each number. I don't know, just do one actually, just do one. Uh because you can't yeah, whatever. So create a function that takes in three names, appends each one to a list, then uses a for loop to loop through each name in the list and print it. Okay. Now create a lambda function that does the same thing as the function. So just put your list in the print statement for number 5. So that gets printed out. If you're on YouTube, just put your homework in the comment section and we'll reply to it. Yeah.
Yeah. Okay.
Okay.
Well, that'll probably be it. Uh, yeah.